Welcome to solverfy.
Okay, so in this exercise we are in the fit of a photographer that need to arrange 6 people for a photograph, okay, in a row. And we need to satisfy some conditions. So how many possible ways that this photographer can arrange these 6 people if the bride needs to be next to the groom? Okay, so for that we're going to consider, let's suppose, the bride and the groom as a whole. Okay, let's one element. Okay, so that means that we are going to have fifth five uh, five places, okay, where we are going to locate the people, and one of those positions are going to contain this pair of bride and groom. Okay, they're going to be together. So we have 5 elements, okay, to arrange in 5 places, right? And one of those elements are the groom and the bride. So here we have 5 possibilities to arrange people. Here we have 5 possibility. Here we have 5 possibilities. Then here we have 4 because the people we cannot clone the people. So if here we have 5 possibilities to put people there. Then we have 4 here. Then 3, 2, and 1. Right. So how many ways we can arrange this? Well, 5 factorial. But we need to be careful because this pair of bride and groom have 2 ways to be arranged. Either the bride is to the left of the groom or to the right of the groom. So there are 2 ways. So this pair has 2 possible arrangements for each position that it's going to be on the row. So that means that the total number of possible way is 2 times 5 factorial, and this equals to 240. You can think this in a different way. Yes, sure. Let's suppose that you have here the 6 positions, right? 1, 2, 3, 4, 5, 6 that are in a row. So the broom, the bride and the groom are going to be here and here. Okay, so can be in these in these 2 places, or in these 2 places, or in these 2 places, or here or here, and you can count this. So these, the possible ways to arrange them are 5, right? So we have 5 possible ways to put the bride and the groom, but we need to consider the shift. I mean, we can change the positions. We have 2 possibilities for each pair. Either the bride is to the left or is to the right of the groom. So here we have 2 times 5. And then we need to arrange the rest of the people, that are going to be 4 people on 4 places. Right? And that is equals to 4 factorial. And this is again 240. So you can think in both ways and you're going to obtain the same result. Now, we need to arrange them in a way that they are not, so now we need to arrange them in a way that the bride is not next to the groom. Okay, so this is a negation of the previous statement. That means that we can calculate this. So the number of ways where the bride is not next to the groom, just to put some notation here, it's going to be equals to the total possible over arrangements. So it is the total possible arrangement of the 6 people minus the value that we calculated in the previous one, because these are the numbers of ways of arrange these people such that the bride is together with the groom. Okay. So this value we calculated in the previous statement, this where the bride is next to the groom, is equals to 240. Now, how many possibilities? What is the total number of possibilities? Well, we have 6 positions, we're 6 people, that is equals to 6 times 5 times 4 times 3 times 2 times 1, right? This is 6 factorial at the end. So the number that we want to calculate it here is where the bride is not next to the groom, it's going to be the 6 factorial minus the 240, and this is equal to 480 ways to arrange these people. Great, and now the last thing that we need to do is to arrange such that the bride is somewhere to the left of the groom. So this is not that hard, because technically if we count all the possibilities, okay, so all the possibilities is equals to t, that we know that is equals to 6 factorial, right? So in all the possibilities of the arrangement of these 6 people, we're counting where the bride is to the left, but also where the bride is to the right. So let's suppose that this is the group. Let's put G. Yeah, that's better actually. So here's the bride, here's the groom. So in this case, the bride is to the left, but because we're counting all the possibilities, we're also counting where the bride is to the right of the groom, right? So basically, in this same position, we can change them, right? So G and B. And technically, because we're counting here all the possibilities, half of them are going to be when the bride is to the right, and half of them are going to be where the bride is to the left of the groom. So we just need to take the half of that number. So we need to take 6 factorial divided by 2. And this is equal to 720 over 2, and this is just 360 ways.